Okay, good morning. So we will start our lecture. Okay, so it's a continuation of what we learned on Wednesday. Okay, so I think I will start from example one briefly, even though I already explained about example one, but I still like go through because we have some time. I think we all the three example we can still finish within 30 minutes. Okay, so you can open up to example number one. Okay, so to calculate FR, the resultant force, and COP, center of pressure. So discuss also whether the driver can open the door or not. Okay, so you have a situation here where this is the free surface and you have a lake. In lake, normally it will be water. Okay, so and you have a car which at the bottom of the lake. Okay, so from the surface is 8 meters, and this is the dimension of the car. Okay, so 1.2 meter and 1 meter. So you need to discuss whether the driver can open the door or not. Okay, so you need to take the center of this door so that you want to check whether the driver can open the door or not. Okay, so how to find? Okay, so this is the first formula. The resultant force Fr equals to PCA. So PC is the center pressure, okay, or the centroid pressure, and at times with the A. Okay, so in order to find this, first you need to find what is PC. So PC, the formula is rho GH. Okay, rho GH. Okay, unless this car is at the angle, then you can take into consideration the sine or the cos theta. Okay, the angle from the surface. Okay, in this case, this is horizontal, so we just take the horizontal formula. This, yeah, correct. So you have three situations. So if vertical, you take this formula. So if at angle, so this is the formula for the angle. Tilted plate, this is vertical plate, and this is horizontal plate. So in our situation, the car is in the horizontal side, so you just take this. So now sine component. Okay, so you replace this. So rho G HC is S plus B over 2. Okay, so S is 8 meter from the surface. So B is the car length. Okay, car length. And you need to divide by 2. So by substituting the value, you can already find what is PC. So it is said lake. So we assume is water. So we take the density of water. So 1000. Gravity is 9.81. The S is 8 meters. And B is 1.2. So divide by 2. So by solving this, you get 84.4 kilonewton per meter square. Okay, so once you already find what is PC, then you can already substitute in this formula to find the FR. Okay, so FR equals to the 84.4 kilonewton per meter square times with 1 meter times 1.2. Okay, so this is, so even though the car is not a square, but we still assume it's a square. So it's better for you to write at the top. So assume the door of the car is a rectangle. Then you can use this formula. Okay, panjang kali lebar. Okay, so 1 meter times 1.2 meter. So make sure all the formulas that you are using is in SI. So if the dimension is given in centimeter or millimeter, so convert it first to meter. Then you can use. Okay, so by solving this, you can find the resultant force, which is 101.3 kilonewton. Okay, so we already settled the first part, calculate the resultant force. Then you want to find the center of pressure. So for center of pressure, so you need to check which formula to use. Okay, so this is the formula for tilted plate. So this is the formula for the vertical plate. Here is not given. Okay. But if you see from here, okay, so you still can use the same formula. Yeah, you still can use the same formula because here you have the sine component. A sine component because it's at an angle. So if no sine, so you can just take the standard formula. So Yp equals to S plus BO2 plus AB cube over 12 divided by S plus BO2 times with AB. So take this formula and you replace all the value. So S is 8, so B is 1.2 over 2. So A is 1 meter. So B is 1.2. Okay, cube over 12. So this is the same value as this CAB. So by solving this, you get 8.61 meter. So meaning from the surface to the center of the door, so it is 8.61 meter. So it's logic. So until the roof is 8 meter, so this is additional 0.61 meter to the door. So that is your center of pressure. So you already settled the first part. So calculate the FR and COP. So then you need to discuss also whether the driver can open the door or not. So it is known that hydrostatic pressure is acting on the door. Okay. So lagi dalam, so lagi banyak hydrostatic pressure. So meaning when the car goes deeper, it's very hard to open the door. So because the hydrostatic pressure will be pushing against the door and prevent you from opening the door. Okay, so the discussion will be whether the driver can open the door or not. Okay, so the moment acting on the midpoint of the submerged door is 101.3 kilonewton. So meaning you want to take at the midpoint of the door. Okay, so you take this 1 meter divided by 2. So that is the midpoint, assume as a midpoint. So or you can write this, assume the moment acting on the midpoint of the submerged door. So you add the word assume. Because in physics, we can do a lot of assumption and we can then calculate. So you do the assumption. Okay, so 1.1.3 kilonewton times with 0.5. Okay, so that is the moment. So you get 50.6 kilonewton meter. Okay, so human can generate, so there's a footnote here, human can generate approximately 1 kilonewton force. So if the human is 100 kilogram mass, so meaning if your kg is lesser than 100, so your force will be lesser. So if 50, your body mass is 50 kilogram, then you only can produce up to 500 kilonewton. 500 Newton, sorry, 500 Newton. So you just compare with this, whether can overcome the moment of the door at the midpoint of the door, which is 50.6 kilonewton. So if you times this, so 1 kilonewton times with 0.5 meter, so you only can get around 1 kilonewton meter, or 500 newton meter. So you are only generating which is 50 times the moment of the driver that can possible generate. So meaning, in order to compensate with this, so cannot, because the driver only can generate approximately 1 kilonewton of force. So 1 kilonewton of force. So you cannot open the door. Okay. So that's why it's better for the driver to open when the car enters the lake. Because on top the hydrostatic pressure will be lesser. Okay, so this is your first example. Okay, any question for the first example? Apa-apa soalan? Okay, so I think I explained more on the lecture, like during the lecture time. So for example one, you can refer back to your lecture video. Okay, on Wednesday. Okay, so we will enter to the example two. So example two and example three, a common question. Okay, the similar question can be asked in the exam. Okay, so for the first part, you need to check whether the value the question is exposed to atmospheric pressure or not. Okay, so because we see here in the previous slide, uh, right? So you know the hydrostatic pressure forces on a plane surface. So there's a statement here. Atmospheric pressure (PATM) can be neglected when it acts on both sides of the surface. So meaning, so you have a situation like this where uh, one side is totally exposed to atmospheric pressure, and in this graph or in this chart, the part of the event, part of the chart or the figure is exposed. So there are atmospheric pressure on both sides. So if the point of measurement is at this point, then you need to minus the atmospheric pressure from the formula. So then you will get something like this. So meaning you just remove this part, the whole part. So you only take into consideration this triangle. Then you will get this. So you have subtract the atmospheric pressure. So we want to find out in our question whether you have the similar situation or not. Okay, so in this case, so it looked like a similar situation. But we read first. A 5 meter high, 5 meter wide rectangular plate. So meaning the plate, this plate is 5 times 5 meters. Okay, 5 times 5 meters. Rectangular plate blocks the end of a 4-meter deep freshwater channel. So only 4 meters are under the freshwater. So it's given. So all these terms you need to take into consideration because you want to calculate the formula, the hydrostatic pressure. So you need to know what fluid is inside. So if oil, you cannot take 1,000. So 1,000 is only for water. So fresh water is still under water category, so you can use 1000. But if it's in the oil or other liquid, uh, so you need to consider the particular density. Okay, as shown below, the plate is inch about horizontal axis along its upper edge point through point A. So meaning the plate is inch at this point A and is restrained from opening by a fixed ridge at point B. So meaning ada penghalang dekat sini at B. Okay, there's a block. So it prevent the plate from going backward. Kalau dia pergi ke belakang, so air akan keluar. So you need to have something to block so that the water cannot go out. Okay, so determine the force exerted on the plate by the ridge. So they asked to find what is the force here. Okay, force here, force experience. Okay, so this is the question. So there are some important information like 5 meter I, 5 meter void, 4 meter the water level, then the fresh water. So all this, please write it down first. So write it down before you answer the question. Okay, so we go to the solution. Okay, the solution. So first, once you get the sketch like this, draw the free body diagram. Okay, so draw this so that you can see. Okay, so the draw similar A, B. So then you have a force Fr. Okay, so this is your S equals to 1 meter, and H equals to 4 meter. So there are two forces. One is Fr acting on the plate. So Fr is at the center of pressure. The center of pressure, and the F reach or the force at reach is at the bottom. So that means there are two lines. So these two lines are very important. I will tell you why. So make sure you draw it correctly at the point. Jangan average you lukis dekat atas. Then the calculation at the back will be a mistake. So you need to know. So they say determine the force exerted on the plate by the ridge. So the ridge is here. So you need to find the force face at the ridge at the bottom. So bukan dekat tengah-tengah. Okay, so draw this correctly. So once you already draw, then you calculate one by one. So first you need to calculate. So you know not much information about average, but you can calculate the FR. FR using the formula that we used earlier. Okay, so this is a horizontal. So you just use this formula. So no sign, no angles involved. So you can just use the straightforward formula. Okay, so average pressure equals to PC. So central pressure. So equals to rho G AC. Okay, so rho G HC. So this is your H. So you are taking half. So the center of this part is over 2. Okay, at the center here. So H over 2. Okay, and please note that this hydrostatic force is only acting on the water part, so not on the air part on top. So you need to minus. So even though the meter the plate can rectangular plate. So the plate length is 5 meter. So you only take into consideration the part covered by the water. So yang bahagian udara itu jangan ambil. So that's why here you only take H. So you are not taking S plus H. Tak. So you only taking H over 2. And then you replace the value. So 1000 times with 9.81. So H is 4 divided by 2. 4 divided by 2. This is your unit conversion. Okay. You solve this, you get 19.62 kilonewton per meter square. So that is your average pressure. Okay, so you already found this. Then you replace this in the formula for FR. So FR equals to P average times with area. Okay, so average pressure is 19.62 times with. Okay, so for hydrostatic force, you only take the the dimension of the one that under the water, under the exposed to the water, because this is hydrostatic force, not a general force. So hydrostatic force is only within the water. So here is 4, and the width they say is 5. So 4 meter times 5 meter. So you get the resultant force to be 392 kilonewton. Okay, so you already found FR. Okay, so then you find the uh, center of center of pressure. Okay, uh, from the free surface. Okay, of the water level. Okay, the line of action of the pressure center, which is 2 2h over 3 from the free surface. Okay, so ini adalah free surface, and we know the pressure will be acting um, below the centroid. So I dah explain hari itu kenapa, because more line of force, the larger line of force will be at the down part because of gravity. So FR, by our understanding, we know that is below the center of this part. So yang ni dia memang not standard 2h over 3 2 over 3h kan, but we can assume that from year to year, the FR is acting at 2 over 3h, 2 per 3 h. So we can assume, this is assumption, walaupun tak ditulis dekat sini, tapi I galakkan during the exam you write the assumptions that you made. Okay, so you assume that the FR is at 2h over 3. Then you replace with the formula. Yp equals to Yc plus Ixxc over Yca. Okay, so here Yc is 2 meter. So you are taking from the centroid. From free surface to the centroid is half. So 4 over 2. So you dapat 2 plus. So yang ni adalah 5, the width times with the part. Yang cube ni, just take the length which is covered by the water, the height. So yang ni adalah bahagian height. So maybe you have a confusion because the formula is AB cube. So which one you want to take as a AB? So AB is this part yang ketinggian dalam air. Okay, so in this case, so ini adalah ketinggian dalam air. So here you take, so 5 is the width times with 4 cube over 12 bagi dengan so yang ni 2, so YC is 2, A is 4 times 5. Okay, so you solve this, so you get YP equals to 2.667. So meaning from this free surface, the length of the center of pressure from the free surface is 2.667 meter. Okay, so you already found this, you already found Yp. Then take the moment. So this is where this free body diagram is important, because you're taking the moment about point A and setting it equals to 0 gives summation of MA equals to 0. So you just write this statement. So just write this statement, then you can get, okay, so here FR. So you already know the location of the force. Yani dekat 2/3H, okay, from the surface. So you tulis FR. So ada dua force, FR and F reach. FR, FR. So from A, because you are say taking from point A. Okay, dari point A seberapa banyak? So you write FR. FR is here. Dari A ke FR berapa? So you need to take here into consideration S plus with YP. Sebab dari surface ke point ni is YP. Dari A ke free surface is 1 meter S. So FR S plus YP. Then dari sini ke F reach. So the force is F reach. Panjang dari sini ke sini is S plus H. Ataupun panjang AB lah. Panjang AB. So you already got all the information. So FR. So this information you get from the free body diagram. So make sure you draw it properly. So solving average. So you want to find average. All the other information you already got. So you rearrange the formula. So S plus YP over AB. So yang ni bawa ke bawah. So the length of AB times with FR. Okay, so S is 1 meter. YP is tadi 2.667. So 1 plus 2.667. So divide by the panjang AB. So A ke B adalah 1 plus 4. So which is 5 meter. Times with FR tadi 392 kilonewton. So you solve this, you get the force at the reach is 288 kilonewton. Okay. So dekat sini FR adalah 392 and the force at the reach is 288. So mana pergi the balance? Okay, so the discussion point, the difference between FR and F reach is the force acting on the inch at point A. So dekat sini ada lagi satu force yang kita tak nampak. So which is taking the remaining. Tadi berapa? So 392 minus 288. So you dapat dalam berapa? So dah 90 plus lah. So 90 392 kan? 392 minus 288 dalam 96. So the remaining 96 ke? No, 100 plus, right? So 104 kilonewton will be acting at point A. So dekat sini pun dia ada force yang acting on the point, on the apa kita panggil tadi? Inch. So at the inch A, so the remaining force is exerted by point A. Okay, so ada apa-apa soalan? Example 2. Any question? Ada apa-apa soalan tak? Okay, so if no question, if got question, please refer back to the video. So I go to the example 3. So example 3 also commonly coming out in the exam. So 200 kilogram. So they already say there's a rectangular gate. So this is a water gate. So to prevent water from coming out. Okay, so the weight of the rectangular part is 200 kg. So it is 5 meter wide. So wide 5 meter wide. So inch at B. So there's an inch here. And lean against the floor at A. So the floor part yang ni dia ada dekat A lah. So making an angle of 45 degrees with the horizontal. So the gate is to be opened from its lower edge by applying a normal force at the center. So force dekat sini bukan, so it's already say the normal force is acting at the center. Dekat sini. So later in the free body diagram, make sure you draw at the center of this plate, this gate. So you apply force at the center, the water will come out. So that's why. So generally the hydrostatic force is acting from the water, opposing this. Okay. So determine the minimum force F required to open the water gate. So meaning first you need to find, so what is the resultant force here? Then if you want to open the gate, so the force given by F must be larger than the hydrostatic force. And then this thing can go up. Kalau kurang tu, dia tak boleh open. Okay. So then the other information is the water is water. So we use the density of water 1000. Okay, so the solution. So the free body diagram you draw first. So from the surface, okay, so no atmospheric pressure involved in this calculation is above. So you need, so the body is fully submerged. Okay, so this is your S. S is 0.5. So it's not 0.5 actually, because the plate is at an angle. So the S will be this way. So this way. So not, don't take this. So this is for the vertical. Vertical or horizontal, you can consider this. But when it is at angle, so the S it will, you need to like connect this to the surface, and you need to see what is the length of S. Okay, and also this, the length of B from point B to point A. So you need to do a trigonometry because the length is not given. So only the height is given and the angle is given. So you can take. So for this, you take you need to calculate the horizontal part. So you take the sine 45. So trigonometry. So B is, the length of B is 3 meters divided by sine 45. Trigonometry. So if you don't know how you got this, so go and refer back to your maths. Okay, so trigonometric. Okay, so the length of A to B is 4.243 meter. Okay, so based on the trigonometric. Okay, and S, so you sambungkan ke belakang. So S equals to 0.5 divided by sine 45. Sama juga. Okay, so the S, so from this point, point B to the free surface, if you draw a straight line, the line of action, so it is 0.7071. So don't take 0.5. So take this value as S. Okay, the average pressure on the surface is the pressure at the centroid. Okay, so pressure dekat sini of the surface is pressure at the centroid, midpoint of the surface, and multiplying it by the plate area give the resultant hydrostatic force on the surface. Yang ni this formula lah. So you will calculate the FR. So FR is acting 2 over 3. So 2 over 3 of the plate is below the centroid. Okay, so first you calculate FR. FR adalah average pressure times with area. So average pressure is rho G HCA. So this is formula from the previous slides. Okay, so density is 1000, gravity is 9.81, AC is 2 meters. So macam mana dapat 2 meter ni? From this formula. So S plus B over 2 sin theta. Since there's an angle, so you need to consider the angle. So S is 0.7071 plus 4.243 divided by 2. So that is your B. P over 2. So you dapat value tu kali dengan sin theta. So you kali dengan sin theta, you can dapat the value of 2. Okay, and the area is 5 times so panjang ni. So 5 times 4.243 meters. Then this is your unit conversion. So you settle this, you dapat the resultant force to be 416 kilonewton. Okay, so you already found this, the value of resultant force. Now you find the YP. Find the distance from pressure center from the free surface. Dari kawasan ni ke sini. This point, the center of pressure. So that is your YP. So this taken for this because it involves a sin theta because of the angle. Okay, so you ambil dari formula ni. So YP equals to S is here 0.7071. So B is 4.243 divided by 2 plus yang ni the submerged body lah. B adalah submerged body. So A is the width. So width is 5 and B is 4.243 cube over 12. Yang ni same lah. So P0 over rho G is so you solve this, you will get this formula. So then you substitute the value. Okay, once you already get the final formula from this, and then you substitute the value, then you get YP equals to 3.359 meter. So meaning from the free surface to this center of pressure, so if you connect, so that is 3.359 meters. Okay, so you already found FR and also YP. So now you calculate the distance of pressure center from the inch at point B. So you calculate from this point to here. Yes, LP. So from point B to the center of pressure is YP minus S. So YP adalah dari free surface to the center of pressure. So but you only want to find the distance from B to the center of pressure. So YP minus S. So S is the one that you calculate here. So you get 3.359 minus 0.7071 equals to 2.652. Okay, dari sini ke sini adalah 2.652 meter. Now you are taking into taking the moment about point B. So from point B and setting it equals to 0. So summation of the moment at B equals to 0. So you dapat, so ada dua force FR and also F. So tulis at both side FR on the left hand side, F at the right hand side. Here it is LP. So LP from point B to the center of pressure is LP, and for F it is B over 2. So B over 2. Okay, so you dah dapat formula ni. So you nak cari F. So you rearrange the formula. So you dapat 2FRLP over B. So yang ni dari formula ni lah. Then you replace all the values that you already calculated earlier. So the force here is 520.02 kilonewton. Okay, so you already found this. So in addition, untuk yang ni dia ada addition. Because it says the rectangular gate, the weight is 200 kilogram. So you need to find the weight of the gate. Okay, tapi you tahu yang ni ada angle. So you need to find the horizontal component of this. So you find the cos. Horizontal component adalah force because you want to find the gravity. So moving downward. So you know the F of the gate is W, the weight, uh, times weight, cos 45. So weight is mg. So m is 200 times 9.81. So this unit conversion times weight, cos 45 is 0.707. So the weight of the gate is 1.39 kilonewton. Okay, so yang ni pun perlu ditambah. So the F total, so F plus 1.39 kilonewton, so you dapat 522 kilonewton in 45. So because the question is asking, so determine the minimum force F required to open the water gate. So you need to supply 5.22 kilonewton. Dari sini 5.22 kilonewton, direction 45. Yang ni 45 lah. You apply, baru water gate ni akan buka. So this water gate will be open. Okay, so any question for the 3 examples? Ada soalan? Okay, so kalau tak ada soalan, yang ni you boleh try lah. So you can try yourself. Maybe during the tutorial we will discuss this. These 2 questions. Answer I dah bagi. So try to find until you get this answer. This is actually quite easy question. If you understand. So if you don't understand, so try to listen to this recording video of our example. Then you know how to find FR and also YP. So try, I think I have 2 questions. Try yourself question 1 and try yourself question 2. So you can see here there's a different densities. It's not no more water. So here pun no more water. So it's given a specific gravity. So you need to know how to find from specific gravity or specific weight in order to get the answer. Okay, so end of chapter, sorry, not chapter 3, chapter 3 part 3. Yes, chapter 3 part 4, I will give as a puzzle assignment and we will have a discussion next week. So that will be on the buoyancy force. Okay, so ada soalan? So any question before we finish?
No, sir.
Okay. So if no question, I think we will finish now. So please follow the assignment and I will upload this video later in the Google Classroom. So thank you.